Yeah.
Okay. We're ready.
Are we good?
Yeah.
Alright, guys, so this is mass spec. We have people assigned to cleaning it, so you don't have to worry too much. This is just about how to use it really quick, how to use it properly, and maintenance. Alright, so first things first, let's say you want to have a sample, you want to go and put it on and run it. If you want instructions on how to set up specific methods, we'll tell you another time. But there's 4 core modules: multi-sampler, pump, column pump compartment, and triple quad. So you want everything to be green before you run. So you basically want to get these all set up for your method. So first, open whatever method you want. I'm going to just choose this one. Open it, then you click apply. Then you go click on, etc. And so this way, it's warming up to your specific parameters. If you don't click apply, it's going to warm up to some random method. So you need to warm it up to your specific method you want. It's going to take at least 10 something minutes to warm up. Alright, so it's going to take some while to warm up. You go and check, click source down here, and then down here, you can see these numbers, the set point and the actual values. And you can see these rise as it's warming up. So this is how you can know if it's warming up. It'll take about 10 minutes. So other things you'll make sure of is you're going to have to go and put in your plate into here. So this is plate 1, this is plate 2. So you can put in these plates. These are just 96 well plates. These are 54 well plates. These are 384 well plates. And so all you want to do is go and put them in. It says A1, so that tells you the position A1. You go and put it in, you right click, you say assign well plates, and then you say what each well plate is. So for these 96 well plates, they're just called 96 Agilent. 54 well plates are called 54 vials. And then 384 well plates are called 384 Agilent 250 microliters. And so if you assign it to the wrong type of plate, it will throw an error if you don't change it. So you always make sure you change this. You want to always go and check here to make sure that there's enough A and there's enough B. So just right click, auto fillings, check these values, you visually check here. You just don't want to run out, you don't want it to be dry. So just make sure there's enough. In general, best practice is if you're using like over a liter of solvent, please make it yourself. Otherwise it's too much for whoever is in charge of refilling. There's column compartments, so here are different columns we use. So you can right click, column assignment, and then you can go and change this position, right one, left one, etc. And it'll match these columns that we have stored here. We have different columns for different purposes, in terms of like how hydrophobic they are. Some of them I use for proteins, some are dirtier than others, etc. And so we program these when we install them. They have like pressure limits and such like that. The other thing to note is that, yeah, that's basically all you need to know here. Yeah. Okay, so other features, we have needle wash here. It's just methanol and water. So basically every time you run your sample, it's going to just be washed with this default. So what happens is these solvents come up here, they mix in here, A and B as a ratio, before they get funneled down to the LC part. So if there is like high pressure or anything, you may have to open this valve, you turn it, open and close, and this is going to affect basically how much solvent goes into the system and how much is released. And so this is a way to like relieve pressure. So let's say you want to flow at like 5 ml per minute because you want to clear out the system. You open this fully. That way, it's basically just going to get defaulted and go to waste and not go through the system. All right, after it goes here, it then goes here. Basically, solvent goes here to run it through. You have a needle here. It's going to basically inject here, pull it up. Sample is going to go here. After that, it mixes the solvent. It's carried through this line to the column. Something you may want to keep an eye on is these here. There are 5 vials. you could just name it vial 1, 2, 3, 4, 5. So you could say go and inject from vial 5. So typically I just like wash solvents here. So these are available to you as well if you don't want to use up a full pipe. After it goes here, this line takes here. Here, this is a heat exchanger. So this is what warms up this right here. This is what warms up your solution. This can burn out, so don't go too hot. Not every column is able to be used every temperature. So don't go too hot. 40 to 60 is probably best. For like each column will have their own specifications we'll look up. Afterwards, it goes from here, it goes here, runs through the column, goes down here, here, and then this is when it hits the MS part. So basically what happens is there's an ionization event that's going to basically ionize and turn all your particles into ions. So when it does that, it basically shoots the ions into the mass spec. And so basically the best practice is there's a thing called like ion suppression. So if you inject samples that are too dirty, they're too concentrated, there's too much stuff, it has non-volatile solvents, it has like detergents, anything that can chlorinate things, those just get stuck there and it affects ionization. And that leads to ion suppression. So if you have a compound that's not really ionized well, this basically dominates the system and you don't see your peak. So in order to see your peaks, you need to make sure that the system's clean. So the best practices is we don't use any detergent or anything in our bottles that we use on here. So that's why we have bottles over here for cleaning mass spec. They haven't been used with detergent at all. They're clean because if you have detergent on here, it'll just stay on the mass spec, and that's why our backgrounds tend to be such, unfortunately. There are other things that will go and coordinate with different things. So like tris is not compatible with the mass spec. It's basically just going to be stuck on there and take a long time to run off. And so if your peak comes out at the same time as the tris ion, it's really hard to see your peak. So that's an issue. So it's basically, if it's organic solvent, ethanol is not good. Anything that's like not volatile is not good. So you need like methanol is fine, water is fine, acetonitrile is fine. All the other ones you're going to want to grill the wrap off or speed back off before you go and run on the mass spec. If they're non-volatile solvents, they're just going to get stuck, it's going to cause issues. So you can just check for yourself if solvents are fine. The other thing is like if you're doing like aqueous solutions, it's on you guys to go and check to make sure your additives aren't going and gunking up the system. So you could just look up what's compatible. Just look up if your buffer is compatible with this. Phosphate's probably fine, but tris isn't. Okay. Okay. So other things to keep note of is I'm gonna open a random data file. Okay, let's look at this one. So you see here how the first minute there's no data. That's because we purposely programmed the method so it's like that, because all the junk that doesn't stick to column comes out in the beginning, and that's kind of what comes at the mass spec. So we basically divert all this stuff to waste so it doesn't hit the mass spec, doesn't dirty it up. So the way you could do that is here, QQQ timetable here. And so you can say at 0 minutes, diverter to waste, and at 1 minute, diverter to MS. So that means the first 0 to 1 minutes, all that stuff's gonna go to waste. At 1 minute, it's gonna go and hit the mass spec. So we recommend this, especially if you have like volatile solvents. So like, you know, if you have a sample that has like DMSO a little bit, you know, try and like minimize as much as possible, but it's in there, and that's why we go and divert to waste to get rid of it. Okay. Yeah, so other best practices is, you know, once it gets to 10 to the 8, it's too much. Like, there's such a thing as saturation that leads to peak splitting. We don't need it to be 10 to 7, it's too high. Like 10 to 6 is fine, 10 to 5 is fine. It doesn't, like, you don't need that much. All you need to do, like, we're mostly using this for is the peak there or not, right? So as long as you could basically see above the noise, it's fine. So it's better to have it more dilute than not. And so just try and dilute your samples, you know, a fair bit. Just do like 1 microliter injections. You don't need like huge termite window. Okay, then the last thing I want to mention is changing columns. So basically, this right here is where you take it off. This on the bottom, just take off with your hand. It's very easy. This one, it's tight enough that you'll need to use wrenches. So use these two wrenches. There's a bigger one, a smaller one. The bigger one comes here. The smaller one you attach. So you have to basically use it to break it apart. And the last thing is, when you take it off, make sure you replace it with this other one. You take these, use it to cap it, or else it'll run dry. Alright, so when you put it back on, this part breaks all the time. This is broken 7 times since we got it. It's like $300 each because of mismanagement. So basically, the reason why it's mismanaged is it leaks from here, and so people use the wrenches and over tighten it. When you over tighten it, it breaks it. So basically this part right here, this is supposed to be able to move like this. You see how this metal, it's a little, can move back and forth. It's supposed to be able to move. If it's stuck right there, it was over tightened, it's just gonna break soon. So basically what I do, you put in the tail end, you put this in, you go and stick in the metal tube into it as far as possible, and then just make sure that it goes as far as possible in. Because what happens is if you go in and put it in like this, sometimes it doesn't reach, and so there's some dead volume, and that's why it leaks. And so that's why you want to make sure that the